Greetings to you all. I welcome you to today's class where we will be discussing the contour model. For today's class, we'll be focusing on contour lines, types of contour lines, rules of contour lines, advantages, disadvantages, landforms associated with contour lines, purpose of contour lines, and characteristics of contour lines. And at the end of the lesson, I will be giving you a homework which you will have to attend to in order to learn more and discover new things on your own. What are contour lines? A contour line is a line on a map representing or showing areas on the land surface which occur at the same altitude. These are not just lines. These are imaginary lines. In other words, if you go to the actual area, you will not be able to see these lines, but here or on a topographic map, you can see them in representation. They join points of equal height above or even below sea level. So it is not only above sea level, but also below sea level. Here at our level, we will be learning about contour lines, mostly about contour lines above sea level. They connect points on the ground that have the same elevation from a standard level, usually the sea, at 0. In other words, the sea is 0 meters or whatever the distance that is used for representation. And then the standard level that is common is the sea. But here, our standard level would have been 300, a distance less than 300 less than 300. In other words, it will be 300, 200, 100, and it will be a standard level. Types of contour lines. Index contour lines. These are lines that appear at every fifth contour line. Intermediate contour line. These are thinner lines that occur between index contour lines. Usually there are 5 lines after each index line. Supplementary lines. Supplementary lines are drawn dotted lines that are used to represent flatter surfaces. So these are the types of contour lines. And furthermore, the contour interval. The contour interval is the vertical distance or the vertical difference in elevation between contour lines. In other words, we see here is 300 and then here is 400, which means our contour interval will be 400 subtract 300, which will be 100. In other cases, the distance might be represented as, for example, 310, 320, 330, 340, 350, and so on. That means that our difference will be 320 subtract 310, which will be 10, or 380 subtract 370, which will still be 10. In other words, the difference here will always be the same at all areas. This means that from here to here, you will have the same difference or distance. The difference between two contour lines is the same. Always remember that. This means that in a map representation, there is no way that the contour interval may differ. Rules of contour lines. Every point of a contour line has the same elevation, which means if you see a contour line and then you see it at other point, it will always have the same elevation or height above sea level. It means that this contour line will always be 400 wherever it goes. Contour lines separate uphill from downhill. Contour lines do not touch or cross each other except at a cliff. As you can see here, there is no contour line that touches. Also, a cliff has not been shown in a manner which shows contour lines that are the same. Contour lines are close together in steep terrain and are far apart in flat surfaces. For example, you can see here, it's not quite steep, but it's still steep. And then here, you can see at a lower level, it's more gentle, which means the contour lines will be far apart. Every fifth contour line is thicker or bolder. This is known as the index contour. Advantages of contour lines. You are able to see gradual or smallest changes. They avoid problems of boundary line. Disadvantages of contour lines. They are time consuming to make for representation. They are difficult to read when lines are close together in very steep slope and where lines and numbers may occur close to one another, causing confusion. Characteristics of contour lines. Uniform slope have uniformly spaced lines, which means that if the slope is uniform, the spaces between them will always be uniform or will be uniform. Contour lines must always close on themselves. This means that contour lines always close on themselves, as you can see here, unless if it's here. But then even in that case, these contour lines will close somewhere at a point which was not represented on the model. The distance between them indicate the slope, which means that the distance between contour lines indicate the slope. If the distance is more, then the slope is steep. If the distance is less, then the slope is steep. And then if the distance is more, then the slope is gentle. Irregular contour lines represent rough surfaces. So if contour lines appear in an irregular form, it means that the surface is rough. But then if they occur in a regular form, they represent a gradual slope on the surface ground. Ground elevation. This is when inner contours have a higher value or higher elevation than the outer contours. And then in contrast, the depression contour line, a series of concentric lines closed contour lines with the inner contour having lower elevation than the outer surrounding, which means if it was a depression, this one would have more value than this one, and then it will bend inside to show a depression. And then landforms associated with contour lines. As we can see here on the topographic map, we have 5 landforms: the valley, the hill, the ridge, the plateau, and the cliff, which are obviously not the same. These landforms are caused or formed by the type of land which occur at a certain area and the form of weathering that has gone about. It means that these landforms are influenced initially by the weather, the rains, the types of rock, and aspects like that, and then end up forming different landforms. They end up occurring differently. And then for our homework, we will be discussing how to determine or estimate contour lines. In other words, you will have to explain to me how we determine contour lines, and then secondly, you will have to explain to me the purpose and importance of contour lines. For example, I will give you one example. The most common purpose of contour lines is to represent the 3-dimensional shape of the terrestrial surface on the bidimensional map. In that case, I thank you for today's lesson. I hope you have a great day and you've learned a lot from today's model and discussion about contour lines.